Good evening, everyone, and a warm welcome to the webinar on Smart Grids of VoltCast 1.0. Thank you for joining us today. My name is Emasha Chathuni and I will be a moderator for this evening event. And we have a fantastic lineup prepared. Before we begin, I would like to cover a few important guidelines to ensure our event runs smoothly. Kindly mute your microphones when you are not speaking to minimize background noise. Please note that today's session is being recorded and will be made available for viewing at a later time. But please remain in the session as e-certificates will be given only to participants who have filled the attendance form published during the webinar. Also, remember to participate in the quiz at the end of the webinar in order to get qualified for the Ideathon. After an hour of engaging content, we will open the floor for Q&A session at 8:30 p.m. So keep your questions ready. Before we proceed, we kindly ask all our delegates to fill out the attendance form. The link is being shared in the chat box right now. Your participation is important to us, so please take a moment to complete it. And also, you can submit any questions related to the webinar during it, and we will address them in our Q&A session. As we continue with today's VoltCast event, I would like to pause for a moment to acknowledge and sincerely thank our esteemed partners whose support has made this event possible. First and foremost, we extend our heartfelt thanks to our title partner, Region Renewables Private Limited. Your support to this event reflects your unwavering dedication to fostering innovation and sustainable energy solutions. Over the past decade, Region Renewables has played a pivotal role in driving our nation's transition to sustainable solar energy. Their commitment to advancing renewable technologies and promoting environmental sustainability perfectly aligns with the mission of our event. We are truly honored to have their support. Thank you, Region Renewables, for your invaluable partnership. Then we appreciate our gold partner, Vario System, for the extensive support you have provided to make this event successful. Vario System leads the industry globally with 30 years of experience in life cycle management, production, and the electronics manufacturing sector. Vario Systems, we are thankful for your great cooperation. And also, we extend our appreciation to our bronze partners whose collaboration and contributions are invaluable. Voltfact Energy Private Limited, Co Energy Private Limited, and Nirvalanka Electrical Installation. Again, thank you all for your contribution to making this event possible. Now let's take a brief moment to appreciate our title partners' contribution with this short advertisement.
The future is bright and solar powered. Meet the Pereiras, embracing clean energy. The Pereiras use region solar power from morning to night. They're not just saving money, they're reducing their carbon footprint. Make the switch to solar. The power is in your hands. Region Solar, empowering homes, powering lives, powering smiles. Tired of rising energy bills? Region Renewables brings you the future of solar power with our cutting-edge commercial PV systems. Harness the sun's power, slash costs, and become a sustainability leader. Region Solar, powering business, empowering tomorrow. Make the leap to solar excellence today.
Thank you for being an essential part of VoltCast. Your involvement is crucial in fostering the discussion and developments that will shape the future of the energy sector. It is now my great honor to introduce our esteemed resource person for today's webinar. We are excited to have Mr. Janith Wijesinghe as our expert speaker for today's webinar on smart grids. Mr. Janith Wijesinghe is an eminent alumnus of the Department of Electrical Engineering at the University of Moderator and currently pursuing his Ph.D. at RMIT University in Australia. He has extensive experience in the field and holds a MPhil and first class BSc in Electrical Engineering. And also, he has served as an electrical engineer at Unilever Sri Lanka and Ceylon Electricity Board, and has also contributed to academia as a visiting lecturer at the University of Moderator and the laboratory demonstrator at RMIT University. We are fortunate to have with us today. Dear sir, we are truly honored to have you with us. With eager anticipation, we are ready to begin today's webinar. Mr. Janith Wijesinghe, we are glad to have you lead this session. Dear sir, the stage is yours.
Okay, thank you. I hope I am audible enough for everyone. Is it
Yes.
okay? Am I audible enough?
Yes, sir.
Okay, thank you. Okay, hi, good evening, everyone. First of all, thank you for the introduction and welcome to today's webinar on smart grid technology. So, we are living in an era where the traditional power grid is undergoing a revolutionary transformation. With the integration of advanced communication technologies, renewable energy sources, and innovative grid management strategies, the concept of smart grid has emerged as more efficient, reliable, and sustainable energy future. However, as we know, uh, with the enhancement of technology, we have to face several challenges in maintaining an efficient, reliable power supply through smart grids. As engineers, it's our responsibility to address these challenges and contribute into creating a smarter world. Oh, uh, okay, the structure of this session can be outlined as follows. First, I will discuss about the overview of smart grid and the requirement of having smart grid than traditional grid. Next, I will describe issues and challenges associated with the smart grids. Then I will discuss some issues and challenges uh, with the smart grid, and then new viewpoint of the smart grid called cyber physical system perspective will be explored briefly. Actually, regarding this cyber physical system is recently formed by some set of researchers in year of 2015. And then I will move to some research topics that may be helpful for your undergraduate projects as well as any postgraduate students in this session. And finally, you have some time to ask any questions regarding smart grids or your undergraduate related things. Yeah. As moving on, I expect your fullest cooperation and support during this discussion. And meantime, if you have any question, please you can use your chat box and send them to me. Okay. These are the structures of traditional and smart grid. Moving to the traditional one, they are centralized power system where electricity generated at larger power plants such as Norachole coal power plant in Sri Lanka and transmitted over long distances and distributed to consumers through fixed network. However, there is some integration with renewable energy sources such as hydro, solar power plants and wind power plants, but we know those are limited. In contrast, left-hand side image shows the structure of smart grid. Basically, smart grid holds some advanced technology. Advanced technology means some advanced control technologies, advanced monitoring technologies, and so on. So those are the things for enhancing the efficiency and reliability of the power delivery. And moreover, they incorporate with real-time communication, automated controls, data analytics for better management of electricity flow, and then integrate with diverse energy sources, and finally response dynamically to changing conditions and consumer demands. Changing condition means something like when there are more demand connecting with the grid, so there can be demand variation within some small time periods, and when there are some new renewable energy sources connected with the grid, so there can be some uncertainties as well as the disturbances. uh, okay yeah, here's some comparison between traditional and smart grid. So let's start with the traditional grid. For decades, world's energy system has been built around the centralized power plants. Uh, so what? So I mean, what are the centralized power plant? Something like they are the sources like coal, natural gas, and nuclear energy. So that is our traditional uh, power grid works. Therefore, the structure is straightforward. High voltage transmission lines carry electricity from these power plants and transfer to distribution network to provide our homes and some other businesses, something like that. And however, this system has some its own limitations. Uh, Especially the controlling part is also centralized, and therefore real-time capabilities are less. Communication between components are minimal, which means that monitoring and managing the grid is largely manual. So in terms of meters, those are analog, requiring manual read. So we know in CEB there is a meter reader who came to our houses in every month and read our meter. Uh, that's how it works. And moreover, because of the traditional system, consumers have little insight to their energy usage. So they they haven't any control part in their hand. So they cannot do anything. They cannot participate for demand response programs. That is the traditional grid, and that is how it works. Then in terms of reliability, so reliability can be issues as well, because traditional grids are less capable of adapting fluctuations in supply and demand. We know supply should be equal to demand. It's the basic of the power engineering. Otherwise, it will be affected to the frequency. So in terms of frequency, it should be maintained right at 50 Hertz. So because of this less adaptability, uh, adaptability means our controller should be adaptable when there is any change in the grid side. So because of this less adaptability, outages can be large, and that can be take considerable time to resolve. That's what actually happened in outages in Sri Lanka. So yeah. In terms of efficiency, there's another concern because energy losses and wastage are higher, and the integration with renewable energy sources are also limited. Finally, regarding flow of electricity, it flows in one direction from centralized power plants through high voltage transmission lines to local distribution network, and finally to our homes. Okay, now moving to the smart grid. The smart grid represents significant leap forward. It integrates both centralized and decentralized energy sources, including renewable options like solar and wind, along with some advanced technologies. In a smart grid, control is decentralized, allowing for real-time monitoring and automated response. So the digital communication network facilitates seamless data transfer and control between all grid components. So if I raise some question, uh, what is the decentralized control? What is the meaning of decentralized control? So if I get centralized control, in centralized control, a single controller manages the entire system, while decentralized controller distributed control action across multiple controllers. So that means in decentralized controllers, those are more efficient than centralized one. So if there is any disturbance in one particular part, we can neglect that relevant controller, and we can work on other controller together for overcome that issue. So moreover, smart meters used to provide real-time data in smart grid environment, and that enables remote reading, dynamic pricing, and greater consumer engagement. Uh, then reliability is significantly enhanced with the smart grid. So advanced fault detection systems and automated responses ensures that issues are addressed quickly and reducing the outage time when there is any fault happens. So regarding efficiency, it improves as the grid optimize energy distribution, reduce losses, and support demand response programs. Moreover, consumers may have access to real-time data, and they can participate in demand response programs and manage their consumption more effectively. For example, we can take something like uh, residential energy management system. So in residential energy management systems, consumers has power to do something in their hands. So that's how they can incorporate with demand response programs. Finally, the electricity flow is much more dynamic, and it can go in multiple directions. These are some, uh, this is only some set of difference between traditional grid and smart grid, and there are more because smart grid is not a simple thing, it's a bit complex. Uh, yeah. So let's move to the key components of the smart grids. Okay, smart meters are the one of the main components to capture real-time energy usage data from consumer end. Then there are sensors and monitoring devices such as pressure measurement units, and then communication networks to facilitate data transmission between grid components, uh, of components, and so it can be wired as well as the wireless. Uh, Then energy management system, we can call it as EMS, or it can be also called as residential energy management system, stand as REMS, to optimize grid operations and performance through real-time monitoring and control. And then supervisory control and data acquisition, we call it as SCADA system, for providing real-time control and monitoring grid operations. And then distributed energy resources such as solar panels and wind turbines. Energy storage system to store excess energy for use during peak demand or when renewable resources are not available. Grid automation technologies to automate grid operation to improve efficiency and reliability. And we know the meaning of the protection and control system, we discussed it earlier. And finally, cybersecurity system to protect smart grid system from cyber threats and ensure data integrity. Yeah, so these are some main components, and note that there are more in a smart grid environment. Okay. So based on the knowledge up to now, we can come up with this definition for smart grid. The term smart grid have been widely used with different definition and meanings. So if you can search in internet or Google Scholar or IEEE Explorer, you can find many different definitions for the smart grid. So essential to the smart grid definitions is the integration of ICT, that means information and communication technology, and other advanced technologies such as advanced controlling techniques with the large scale power networks to enable electrical energy generation, transmission, distribution, and usage to be more efficient, effective, economical, and environmentally sustainable. So what do you think about a smart grid? It's not simple as we think, and it is integration of everything together. Okay, so why we need a smart grid over traditional grids? Because when we talk about this smart grid, someone can ask this question: why we need this type? Because still in Sri Lanka, still we have a traditional grid, but there are some developing countries, they are doing research on these smart grid technologies, and they have some microgrids. Microgrid is something like subset of the smart grid. So the reason is, in recent years there have been increasing demand for cleaner energy generation and more efficient use of energy due to environmental concerns, as well as limited availability of non-renewable energy sources such as coal, gas, and oil. So regarding the term of increasing demand, recent World Energy Outlook report indicates that the global energy demand is set to grow by 25% by 2050. And energy efficiency is critical factor on energy supply while supplying increasing demand without affecting the environment. So anyone can download this World Energy Outlook report, and I recommend to go through this report, and it explains about some prediction about some prediction demand for future, and prediction of renewable energy generations, and uh, the targets of any targets of renewable energy targets for the in future. Something as an example, I can get in China, 15% renewable energy target was achieved in 2020, and an even more ambitious target of 86% of renewable energy by 2015 has been recently set by them. So that kind of data you can find out from World Energy Outlook report. Uh, yeah. So therefore, the integration with advanced technologies is needed in order to make these energy supplies more reliable and secure. Because we know when we integrate with these renewable energy sources, uh, it introduces some new challenges to the system. So that's why we need some advanced technologies to overcome these matters. And so if we take these all matters together, such as how to supply and use electrical energy in more efficient, effective, economical, and environmentally sustainable way, smart grids are the new paradigm for energy supply and use in response to these challenges. Okay. Yeah. So here I get some example to explain bit about this matter, and look at this graph, and it's about the ratio of peak and average demands in different states in Australia. It can be seen that between 2014 and 2015 period, they tried to reduce peak versus average ratio, and some states reach the value closer to 1. So my point is reducing peak usage and lowering the ratio is an advantage for any nation because it would increase the capacity of energy supply with more margins to accommodate higher energy needs without building new power generation plants. Another way to increase capacity is, without building new energy plants, the way is reduce unnecessary waste. For example, the longer distance transmission of electricity accounts for substantial portion of energy generated. Simply that means in long generation transmission system, there is more waste of energy. So this wastage of generation can be mitigated by locating generators close to the point of consumption. This concept is usually called as distribution generation, and it comes in smart grids concepts. Okay, now try to answer this question. As a hint, think about the nature of renewable energy such as solar or wind, and you can use chat box to send the answer to me. And meantime, if you want, you can get 5 minute break, and I will come up with this question in shorter. So use your chat box and send me the answer. Yeah, the question is, what are the technical challenges when integrate renewable energy sources into a smart grid? As a hint, think about the nature of renewable energy, such as solar or wind. Lack of knowledge about, yeah, that can be an issue as well, but I need more specific answer about this renewable energy. Yeah, I think I got the answer. It's not available in there. Okay, yeah, that's correct. So moving to this question, generally, the answer is intermittency. Intermittency refers to the non-continuous nature of renewable energy generation due to its dependence on natural conditions such as seasonal variation and weather conditions. So intermittent generation can lead to rapid changes in power supply, making it difficult to match supply with demand in real time. Okay, thank you for the answers. I got the answers for that. Okay, let's see what are the key challenges are associated with this smart grid concept. Okay, now you already know one of them, that is the intermittency of renewable energy generation that affects electricity quality. And the second one is large scale networks of small distributed generation mechanisms such as photovoltaic panels, batteries, wind and solar, plug-in hybrid vehicles, which generate and store electricity closer to the point of use. And then uncertainties happen due to interaction of energy market mechanisms, refer to unpredictable fluctuations and risk associated with market-driven pricing, regulatory changes, and consumer behavior in competitive energy markets, which impact both producers and consumers of electricity. Finally, fourth one is another aspect is how to use ICT and other advanced technologies such as smart meters, telecommunication technologies to enhance efficiency of energy use. Okay, so the question is how to address these challenges. It required several key technological advances. On first, control mechanism need to be distributed. In first or second slide, I talked about what is the meaning of this distributed control. So I repeat it again. In distributed control, normally we give the controlling action not only for one controller, it's distributed within some controllers. So controlling action is more efficient than centralized controllers. So that enable the lower communication needs if grid components such as source, loads, and storage units, uh, and that can be controlled locally, uh, or they can make some decisions by themselves. But if we consider centralized controllers, that uh, separate separate units cannot get any decisions by themselves. That is the disadvantage of this centralized control. And then there should be a relatively accurate prediction of demand at the distribution level, estimating demand in any part of the grid in a few hours or days in advance. So as an example, if we have some demand prediction as well as generation prediction, we can do more precise control because we already have some data for future dates. Uh, Yeah, and next there should also be relatively accurate estimation of energy generation. That is what I mean in earlier sentence, from renewable energy sources such as solar panels and wind turbines. This requires linkage with weather forecasting, so intermittent energy sources can be smoothly integrated with the grid. We know using AI and some machine learning techniques, we can forecast the weather as well as renewable energy generation uh, in for the future dates. On fourth, peak demand should be reduced to achieve a more efficient grid through methods such as load shedding, intelligent load management, and dynamic pricing. So now you know what is the reason of this peak reduction. So if we can reduce the peak demand, there is no need for generate no need for build new generators, new generation plants. We can use our existing ones for supply that by demand. Finally, advanced energy storage technology is also needed. Uh, that helps save peaks in energy demands. So all of these issues and challenges require systematic approach to deal with. Cyber physical system is the term that provides such a paradigm that can help resolve them in systematic way. Next slide onward, I will discuss about cyber physical system application. It's in smart grid briefly. So regarding this cyber physical system, regarding smart grid, uh, if we want to discuss about this smart grid, we need something more systematic way, because uh, we cannot analyze it in simple way. That's why we are use this kind of perspective. So cyber physical system is not smart grid, but this is something like two concepts, but we can match both concepts together, and then we can deal it with very easily, rather than talking about talking talking about smart grid without any structures. Okay, I think we have a question. What's the load shedding? Load shedding is, there's a question, what is the meaning of load shedding? Load shedding is something like uh, load shedding is shutting down the power in some specific part of the country. So let's say, as an example, uh, I can get, let's say, some part of the generation is broken and we cannot meet the required demand, so that we can equal the supply and demand. That means if we cannot if we cannot supply, if we cannot that make that equality, our frequency will get drops. So because of that, we can solve it using this load shedding. So so we neglect some part of demand. In that way, we can get supply is equal to demand. That is the simple definition of this load shedding. Uh, so I think you remember in past days, there is some schedule in some area of Sri Lanka. There is no power, and after that the power got back, and in some part of this country they have same issue, something like that is the load shedding. So CB is trying to make their supply is equal to demand, then they can maintain their frequency at 50 hertz. So to do that, they have to shut down the power in particular area of Sri Lanka. So that's what happened in past days. And I think you got the answer. If you want any further explanation, please drop any message. Okay. So cyber physical perspective of smart grid, actually this concept is uh, firstly presented by distinguished Professor Singyo Yu in 2015. So uh, if you want, you can search this topic and you can read it more about that. This is new concept, and we can easily discuss about the smart grid in this way. So, such as smart grid definition, there are more definitions for cyber physical system concept. However, the US vision of cyber physical systems is more oriented on connection between embedded system and the physical world. Now the question is how to match a smart grid into cyber physical system. Okay, here I request to listen this carefully because there can be some confusion, and this perspective is a bit complex to understand. Yeah. So simply, a smart grid smart grid has a physical system that's our power network. Okay. In other hand, cyber system can be represented by sensors, ICT, and advanced technologies. So we can easily match this cyber physical system into our smart grids. And if we consider characteristic of typical cyber physical system, we can highlight these characteristic that also include in smart grids. Okay. Yeah. First one is integration of real and virtual worlds in dynamic environment. For example, physical systems, that is simply our power network, provide inputs to cyber physical system control centers for simulate models to identify how the physical system perform in future times. That is something like renewable energy predictability. Uh, Second one is dynamic connections and interaction between components in both physical and cyber system through communication networks. For example, ad ad hoc networks are one example for this feature. An ad hoc network is a chain of devices that are connected to each other instead of connecting through a central access point. Okay. And next characteristic is real-time parallel computation and distribution information processing of big data and data streams that is required in order to help deliver timely decisions for smart grid operations. So note that smart grid is critically time manner because there should not be have some time delays inside the communication networks. So finally, self-adaptation, self-organization, and self-learning capabilities can be identified, uh, and through them, cyber physical system can respond to faults, attacks, and emergencies in order to enable smart grids, reliable and safe energy supply. Okay. In previous slide, I explained about how smart grid becomes cyber physical system. Yeah, there can be some confusions for you. It's okay as undergraduate that theory may be bit complex, and however, this is in this perspective too, there are some challenges to overcome because there are some specific characteristic of power system that other physical system do not have, which introduce new challenges to cyber physical system perspective. So if we consider about some robotic manipulator systems, it's something like new physical system. Uh, it's simple than this power network. So power network have some is something more complex. So that's why it introduces new challenges to cyber physical system perspective. And here our physical network is energy network, and that require time critical, highly connected components to work together in real time to achieve system stability, well regulated voltage and frequency, and fast response when new energy needs are demanded. Okay, therefore, this time critical control must be executed and stability should be maintained in order to have uninterrupted energy supplies regardless of uncertainties and disturbances. Here, you can note this word uncertainties and disturbance. That is the main thing we have to solve in the context of smart grids. Finally, we can make some conclusion. That is, network stability and functionality are more crucial than other engineered networks such as logistic and transport networks and even communication networks. I mean, they are important, but this in network is stability thing and functionality of the control system is more crucial than others. Therefore, as power engineers, we have more responsibility to ensure reliable energy supply even when there is uncertainties and disturbances. That's why research and development is more essential for any nation. Before moving to the research interest, let's see how to improve cyber physical relationship in smart grids. It can be described by 6 key functionalities. First one is high dependability, so that the system has to be repaired uh, in a simple and timely manner when there is fault occurs, and maintaining accessibility even the fault occurs. Then high reliability ensures the system can continue to operate even in presence of disturbances and uncertainties. Um, and then high predictability guarantees the specified outcomes such as renewable energy predictions within any time spans when it is required to operate accurately. And then high sustainability embedded with self-healing and adjusting mechanisms and adapting to changing environments. For example, we can say when grid conditions get changed, our controller should be adaptive with that change. So we can we can introduce some novel concept for this one. We can look at grid impedance or grid strength, and based on that we can uh, make our controllers adaptive. That means in real time, in real time manner, that our controller, let's say if we have PI controller, our uh, proportional gain and integral gain should be time varying coefficients. In that way, we can make our PI controller adaptable. That's the meaning of this adaptive control. Okay, and then high security means system should be protected itself from unauthorized access and attacks, and finally, high interoperability enables effective communication among system components. So these are the six functionalities uh, that can ensure this cyber physical system perspective more strong. So this is an overview of cyber physical system laboratory setup. So take some time and try to identify each components. So using this kind of setup, we can do simulation, and we can work on anything which I mentioned earlier. We can make new novel controllers. We can add renewable energy sources using MATLAB models, and we can see how our prediction works, and with the predictions, how our control actions going on, something like that. And we can introduce some disturbances, uncertainties in externally, and we can see how our controller works when there is disturbances, something like that. Yeah. Normally, in research, we use MATLAB for this kind of controlling simulations, and there are some more softwares for that as well. And here you can see this OpenRT device. OpenRT is the OpenRT used for real-time simulations. So first you have to do some modeling and simulations in MATLAB environment, and you can model it in RTLab, and within RTLab it makes some mathematical models of your MATLAB code, and in real time manner it works, and we can see how our energy network performs in real time. Real time means uh, our laboratory setup is equal in real conditions. Yeah, that's the simple meaning of real time. So if someone have any idea to do your postgraduates in smart grid, you can think about this kind of setups as well. It's very novel and very easy to publish your work in research world. There's a lot of opportunities around the world. Yeah. Here is some potential research topics related to smart grids. In this session, I am going to talk about uh, some research topics because it may be required for your uh, undergraduate final year projects. If someone have more interest about these concepts, you can select one of these and you can work search on that, and you can make your own solution for that. Okay, first, integration of renewable energy sources in smart grids. Under that topic, you can explore methods for integrating intermittent renewable energy sources like solar and wind into smart grids while maintaining grid stability and reliability. As an example, you can work with robust controllers to ensure reliable supply when there is some uncertain environment. Uh, uh, Regarding robust controllers, as I know, in our undergraduate syllabus in Sri Lanka, uh, we study about proportional integral controller, but there are more controllers. You can search about that. As an example, we can say model predictive control, sliding mode control, and proportional resonant control, fuzzy logic based control, something like that. They are more robust. Robust means when there is some disturbances or uncertainties, our controller is stable against it, but PI controller may have some more fluctuation, and there is more possibility to get unstable the system. Yeah. Then cybersecurity in smart grid networks mean investigating strategies and technologies to protect smart grid from your cyber threats, ensuring the security of data. As example, someone can make communication network using Arduino or Raspberry Pi boards, and you can explore how to react your network when there is external disturbances, something like that. So regarding this one, you can use state space modeling model for uh, this kind of Raspberry Pi based network, and you can put some disturbances as an example. For disturbances in uh, you can use simply sine wave. Just put sine wave as disturbances and see how your controller reacts for that disturbances. That's how simulations related research works. So I mean, no need to connect solar panels or wind external to your system and see how they react, something like that. So you can simply put some sine wave as disturbances. Then we can explore on advanced energy storage solutions for developing innovative energy storage technologies and their role in balancing supply and demand in smart grids, particularly with high penetration of renewable energy. For example, we can find out how to balance battery state of charge, that means battery SOC level, in effective way to use our using novel controlling theories. And then demand response or consumer energy management is another area for research. So based on the role of consumer behavior, we can analyze how to optimize energy usage in effective way, something like residential energy management system, and and from that we can contribute demand response programs in smart grid that I mentioned earlier. Then microgrids and decentralized energy system. As an example, optimized active power sharing between decentralized system can be discussed. That means active power sharing refers to the distribution of required power among different energy sources within a microgrid or decentralized system. The goal is to balance the supply and demand efficiently, minimizing losses and enhancing the stability and reliability of grid. And artificial intelligence and machine learning in smart grid is very important area. You can work on that because predictability is usually done by using these techniques. As example, predictive maintenance and energy forecasting can be identified. Finally, electric vehicle integration with smart grids explore the challenges and opportunities of integrating electrical vehicles into smart grids, including uh, vehicle to grid V2G technologies and their impact on grid stability. Uh, yeah, so there are more research area in this context of a smart grid, and you can find it from Scopus, Google Scholar, and as well as IEEE Explorer. Yeah. So here is an example of control problem that can be happen in smart grid environment. The DC link can be initiated by solar, wind, or battery connected through converter. Then DC link is connected to the grid via voltage source inverter. That is mentioned as DC to AC inverter. That means direct current into alternative current. So this system simply called as grid following inverter. And there is another topic as grid forming. This is not type of grid forming. This is grid following inverter. So someone can consider the voltage regulation of DC link when there is unknown uncertainties at solar or wind. Also, state of charge of battery energy storage system are also possible. Uh, I mean, I think you can see this large blue color box. Uh, Inside this, uh, uh, in right hand side, you can keep it constant and you can only work on this DC link. So regarding this DC to DC converter, you can work on that. Because regarding this DC link, we need regulated voltage. That means we need constant voltage to work our DC to AC inverter properly, so that you can find some novel controlling techniques for make this DC link at constant voltage, something like that. So, and next thing is on the other hand, some can keep this DC link constant by assuming well regulated voltage at DC link. That means you can simply connect DC voltage source, this DC link, and you can remove these solar, wind, and battery energy systems, and you can work on rest of the things. Uh, and now your intention should be controlling action of DC to AC inverter. Uh, in that kind of system, you can consider robustness of the controlling actions when there are disturbances such as sudden variation in power demand. That means, let's say, we have variation in our active power or reactive power. So we need to respond our DC to AC inverter quickly without any oscillation, without any steady state errors. So you can work on that. Then your research topic should be you have to find out some new way to inject that required active or reactive power in more robust way some without oscillation and steady state errors or overshoots, something like that. So if you take traditional PI controller, you may see that kind of oscillation and overshoots. So you have to find out some new way to overcome that issues. So these things can be considered in your final year projects, and that's very new area, and you can work on that. Uh, I, I think in Sri Lanka, I didn't see any work on this type of concepts. Yeah. So regarding various controllers, uh, our conventional control is proportional integral controller that I mentioned earlier. So other new controllers have more capabilities than PI controllers. So based on comprehensive literature reviews, you can find out what is the state of art and what are the real world problems that needed to be identified and solved as engineers. Okay, so I put this slide because if if someone want to find out more theories and concepts regarding smart grids and its applications, uh, or it can be some new control techniques, you can use Google Scholar and go through these profiles and find recent publication. So you can see these are the highest cited researchers in smart grid field. And it should be mentioned that this presentation is based on the research and finding uh, findings obtained by this distinguished Professor Singio, you and myself. And then I think in my end presentation is over. Now we can move to the question and answer session. Yeah, I think over to you.
Thank you, Mr. Janith Wijesinghe, for that captivating session. We will now move into our Q&A session. This is your chance to engage directly with our expert. Please enter your questions in the chat box or through the link.
Yeah, you can contact me for your projects. You can get my email from the organizing committee. But these days I have more works. I am a bit busy, so if I have whenever I have some free times, I can contact you and give some uh, give my help within my scope. So regarding this A1200 current sensor, it may have some noises. So you may require some more. Can I know what is your? Do you use any Arduino or Raspberry Pi? Those are direct messages. I will read it. ESP4 Wi-Fi connection. Yeah, I think actually I did this thing in my final year project. The question is, I have made simple smart grid for my home to calculate current and power with an algorithm and A1200 current sensor Wi-Fi switches. How can I improve it? Improve should be made from the coding part because the same thing done by me in my final year project while I'm doing my bachelor's. So I find out that there are more noises in current sensor output, so that may lead to give some wrong answers regarding this power, uh, your power and the current. Actually, first the question comes in current, then it comes to power. So then, yeah, there are more sensors you can buy it, but I think those are a bit expensive. Uh, I also use some basic current sensor. Uh, I think you have to work more on your code because it can be the issue for if you get any wrong answer for power. how we protect our smart grid from cyber attacks. Yeah, so this is uh, this is full research question. In this, you ask about how protects our cyber attacks. There are a lot of research going on in these days about the cyber security of smart grids. So I think I cannot give you direct answer how to protect a smart grid from cyber attacks. So I refer to read about this matter more. You can find out more papers on IEEE Explorer. If you want to read about more, you can simply contact me and I will send more readings about that. I think it would be better because answer is not something kind of direct answer. What are the when energy, what are the aspects to be considered in an energy storage when it is connected to smart grid? Aspect means uh, when energy storage connected with smart grids, normally energy storage works, the charging part of energy storage uh, should be done via renewable energy sources like solar as well as wind power plants. So our controller actions should be more precise. That's the main aspect to be considered when you are designing a energy storage system. And other thing is state of charge. So if you have five base means battery and energy storage systems. Uh, if you can make your SOC in equal when it's discharging, that would be much better. So in that way, you can protect your battery energy storage system. Uh, and it should be mentioned that discharging part uh, is only done when there is any when our system need more power. Let's say it's in our peak time, something like that. So and mm, there are some basic considerations, like battery capacity and so on, but these are basic things. The critical point is your controller. Controller should be more precise to protect your battery and make uh, supply reliable energies to the grid. Career, are there any career opportunities emerging from smart grid technologies? Uh, I think uh, if I get career opportunities all over the world, there are more career opportunities. Not, but I think in Sri Lanka there is very less opportunities regarding these smart grid technologies. Uh, but in developing countries, there are more research going on. Even in Australia and in RMIT University, University of Melbourne, something high ranked universities, they are in these days they are doing more research on these smart grid technologies, and obviously they have more opportunities after their studies, because these are the things in future that happens in future. So I think it's good to know about these smart grid technologies. And so basic is the power engineering and concepts theories. So no need to be follow smart grid specifically. You can read it about that and you can learn other things as well. Because smart grid, if you consider smart grid, you have to uh, learn about power electronics, power system, as well as control. Yeah, as I mentioned earlier, the integration of all theories uh, happen in these smart grid technologies. So if you have any questions regarding your final year projects or anything, you can contact me via my email. You can get my email from your organizing committee. And I haven't much time to supervise them, but I can give some help, or I can find out some papers for you, something like that. Okay, okay. I hope I answered every questions, and yeah, opportunities are everywhere. You can work hard and you can dedicate on your work, and I hope you, all of you, are doing well.
Thank you for your engaging questions. We hope our expert has provided the answers you were seeking. A heartfelt thank you to Sir for offering your insightful perspective on those questions. As we
Yeah,
bring
thank you
our
for
session to
inviting me.
thank you,
Yeah,
sir.
you can continue. Yeah.
As we bring our session to close, I would like to express my heartfelt thanks to everyone who played a part in making this event success. I now invite Mr. Emmanuel Hashika, co-chair of VoltCast, to deliver the vote of thanks and outline the process for our upcoming quiz. Mr. Hashika, over to you.
Thank you, Emasha. So I want to express my sincere thanks on behalf of Power Energy Society of IEEE Student Branch, University of Ruhuna. So thank you, Engineer Janith Wijesinghe. Thank you very much, sir, for spending your time to share your valuable expertise with us. So those are like super valuable for us. And your presence here is like super great honor for us also, sir. And I'm sure like all the participants out here are like asked questions and got involved in this session very much, so that they got a very clear understanding about smart deep grid technology. So we expect your kind support for these kind of uh, sessions in future too, sir. So as a response, sir, please accept our token of appreciation for for your support given us on today's so so please accept our token of appreciation, sir. uh, thank you very much for what you have done during this VoltCast event, sir. And also, I wish to express our sincere gratitude to our generous sponsors. Uh, our title sponsor is Regan Renewables Private Limited, and our gold partner is Vario Systems, and our bronze partners, there are three bronze partners: Wolfpack Energy Private Limited, Co Energy Private Limited, and Nirvalanka Electrical Installation. So your support has been instrumental in making this event a success. So we truly appreciate your commitment on this course, because without you guys, it's hard to continue our World Class event. So thank you very much, and we look forward to continuing this fruitful collaboration in future also. So further, I would like to thank our moderator, Emasha and Sue Masters, and to all the members of WorldCast organizing team for their contribution in making this event a success. And also, since we are came to the end of our webinar session, can you turn on your videos to take a small snapshot to have it as a remembrance of our event? Thank you very much, sir, again for sharing your valuable insights today.